Okay, now let's try to see these new formulas that we just came up with in action by trying to do the following. Someone will give us a logarithmic expression, and I want to basically simplify it and just write it as a sum or differences of logarithms as best I can using these properties. So let's recap the properties. Remember that log base b of b is just 1. Log base b of 1 is just 0. Those you can just think about and see by definition of logarithms. The logarithm of a product is the sum of the logs. The logarithm of a quotient is the difference of the logs. And a logarithm of x to the y power, that y can be pulled out in front as a coefficient, and I see y log of x. Okay, so let's see if we can see those things in action with some of these things. So remember, the question in each case is, can you simplify this log expression to be just the sum or differences of logs and nothing else? Log base 3 of 3a divided by b. Okay, well, here's how I think about it. I see this is a log of a quotient. The log of a quotient is the differences of the logs. So using that formula, I can write this as log base 3 of 3a minus log base 3 of b. These two things are equal by that formula. Log of a quotient is the difference of the logs. What about the 3a? Well, that's actually a product. So the log of a product is the sum of logs. So in fact, this equals log base 3 of 3 plus log base 3 of a, and then I still have this term, minus log base 3 of b. But what about log base 3 of 3? Well, that's something we should know. What number is that? That's the exponent I have to raise 3 to in order to make it equal 3. What exponent of 3 gives me 3? Just 1. So in fact, this could be simplified even further to 1 plus log base 3 of a minus log base 3 of b. So there is this expression in an equivalent form, but just using sums and differences of logs in a very simple way. So I was able to untangle all that product and quotient thing into this formulation. These are equal by the properties of logarithms. Okay? That's why I use the formulas. Let's try some more. It's so much fun. Log base 6 of 6 square root of 5 divided by square root of 6. Well, here again I see a quotient. So I could write this as log base 6 of the top, 6 square root of 5, minus log base 6 of the bottom, square root of 6. Okay, what else can I do? Well, this is actually the log of a product, so that's the sum of the logs. So in fact, this equals log base 6 of 6 plus log base 6 of the square root of 5 minus log base 6 of the square root of 6. Maybe that's as best as we can do. Turns out, actually, we can make this a little bit simpler. First of all, log base 6 of 6. That's just 1 again. And these square roots are actually 1/2 exponents. So let me write that in. So this is 5 to the 1/2 exponent minus log base 6 of 6 to the 1/2 exponent. And the reason why that's useful is because now you can remember that property that if I have inside the log something to a power, that power can come out as a coefficient. That was that last property that we looked at. Let me show you that one again. That was this property right here. See, log of something to a power, I can pull that power out in front as a coefficient. So if I use that right now, I can actually simplify this a little more. This is 1 plus, now that 1/2 is out in front, log base 6 of 5, minus, now that 1/2 is out in front, log base 6 of 6. Oh, wait a minute. Log base 6 of 6 is 1 again. So this number is just minus 1/2. And I've got a 1 out in front, so 1 minus 1/2 is just 1/2. So in fact, I see this equals 1/2 plus 1/2 log base 6 of 5. So in fact, that is the simplification of this really complicated thing. this complicated thing is identical in numerical value to 1/2 plus 1/2 log base 6 of 5. And I was able to find that by just simplifying. So you can see how dramatically easy it is. If you had to evaluate this thing, it could be hard. But evaluating this looks pretty easy. Just find log base 6 of 5 using a calculator or something, multiply it by 1/2, and then add 1/2 to it. You get it, instead of doing all that complicated stuff. Just, again, illustrating the power of these properties of logarithms. Let's try another one. Log base 3 of a plus 3b. Well, some may say, okay, the log of a sum is the sum of the logs. So this is log base 3 of a plus 3 log base 3 of 3b. But they would be wrong. This is classic mistake number 9.
The log of the sum ain't the sum of the log. Number 9.
Number 9.
Number 9.
The log mistake. The sum of the logs is not the log of the sum. So in fact, there is no simple way to write this. This is just itself. There's no way to make this any simpler. There's no formula for that. Even though you might say, hey, wait, the product of the product here is the sum of the logs. Yes, but I can't undo that. Can't undo that. So that's the best you can do. A little trick problem there to sort of get you thinking. All right, one last one. Log base 10 of the 5th root of a squared b to the 4th, all divided by c cubed. Looks really awful, but watch how we can do this. First of all, a 5th root is the same thing as raising something to the 1/5 power. So in fact, this is just log base 10 of what? A squared b to the 4th over c cubed. And I raise the whole thing to the 1/5 power. Well, now that 1/5 by one of these laws of exponent and one of the laws of logarithms, that 1/5 log of something to a 1/5, I can bring that out in front. So when I do that, I see that this equals 1/5 in front times log base 10 of a squared b to the 4th over c cubed. But that can be simplified a lot, because I see a quotient, log of a quotient, that's the difference of the logs, using that property that we talked about earlier. So what I see here is the following. What I see is that this equals the difference. So I still have that 1/5 out in front. Log base 10 of a squared b to the 4th. And then I have a minus, and I actually have that 1/5 in front of there, or I could put a big parentheses around it if you wanted, big parentheses, log c cubed. So there's the log of a quotient, difference of the logs. What does that equal? I still have that 1/5 way out in front of everybody. And then what do I see now? Now I see, well, this is log of a product, so that's the sum of the logs. So I just keep using these formulas again and again to really drill this home. So log base 10 of a squared plus log base 10 of b to the 4th. And then, oops, and then don't forget, I've got that minus log of c cubed. Now I can use, close my parentheses. You don't want to keep your parentheses open. My God, you get a draft. But now I see log of something squared, log of something to the 4th, log of something cubed. So I can take each of those exponents and bring it out in front. So this is a really great property, if you're careful with it. 1/5 times 2 log base 10 of a plus 4 log base 10 of b minus 3 log base 10 of c. And you can distribute that 1/5 if you want it throughout. I'll do that. I don't know why. So I have 2/5 here, log base 10 of a, plus 4/5 log base 10 of b, minus 3/5 log base 10 of c. You'll remember the original question was log base 10 of the 5th root of all that stuff. And I was able to rewrite that into this very tidy form. Well, not tidy, but it's very simple. It's just log terms that I'm adding or subtracting together with coefficients. So in fact, what you can see is using these properties of logs, we're actually able to express these kind of objects in a much simpler way, just by doing this. So that's sort of neat. By the way, one little teeny stupid thing. Don't ever read this as log base 10 times a. It's not. It's a function, log base 10 of a, or log base 10 evaluated at a. Just a little teeny point in case you're reading a children's story. You don't want to say log base 10 times a, because your niece or nephew is going to say, what's going on? What are you talking about? You can't. Log base 10 of what? Log always has to have something that you're taking the log of. It's like I can't say, square, because you got to say, well, square of what? I can't say square root. You got to say square root of 25, and then 5. Cool. Anyway, there are some wonderful examples where you can just simplify complicated-looking things and make them look, well, many pieces, but each piece easier. Just using the properties of logs. That's the point. Properties of logs. Enjoy.